Hi everyone, let us discuss this example. So in this example, we have to verify Green's theorem. So they have given a function P, Q and a curve C. Okay, C is a triangular region we have and we have to verify Green's theorem. So let me write a statement of Green's theorem first. So by Green's theorem, do you remember the statement of Green's theorem in previous videos? Already we have seen that statement is integration over C P dx plus Q dy is equal to double integration over D deba Q by deba x minus deba P by deba y dx dy. Okay, so this is statement of Green's theorem. We have to verify, that means we have to work on left hand side and right hand side. We have to find values of both sides and we have to prove that both of them are equal. Then we can say yes, Green's theorem is verified. See here, line integration over C, that means whatever the region we have, we consider just boundary only. C means what? Boundary of that region. So let me show it here. So suppose you have a region like this. So C is a boundary of that region and D is a region enclosed by C. That is, this region is called D and C is a boundary of that region. So when we solve line integral, we solve on a boundary, and when we solve double integration, we solve on that region. Okay. So yes, we have to find values of both sides. So what will we do? We will start to work on right hand side first. Let us find its value. See, P and Q are given to us. So let me write here P. What is our P? P means P of xy, which is 2x minus y plus 4, and our Q is 5y plus 3x minus c. Here we want partial derivatives. Let us find derivative of P with respect to y. We want its derivative with respect to y. Addition, subtraction, we can take separate derivatives. Derivative of 2x is 0. Since we are finding derivative with respect to y, so x is a constant, derivative will be 0. Derivative of 0, I will not write anything here, so minus. Derivative of y is 1, so let me write 1. And 4 is a constant again, so derivative will be 0. So deba p by deba y is minus 1. Let us find deba q by deba x. We are finding derivative of q with respect to x. Y is a constant, so that's why 5y is constant, derivative will be 0. Plus, I will not write 0 plus, supposed to write 3 constant outside, derivative of x is 1, right? And minus 6 is a constant, so derivative will be 0. So that's why deba q by deba x is 3. So let me write here right hand side is equal to double integration over d deba q by deba x, yes, its value is 3, minus deba p by deba y, its value is minus 1, but you know minus minus plus. So let me write here plus 1, and after that we have dx dy. Okay. So let me write it here, the next part. So 3 plus 1 is 4. So it's a constant, will come outside. Okay. So just a minute, let me write here. So 3 plus 1 is 4 and 4 is constant. So that's why outside double integration over d dx dy. See here we have a double integration without any function getting. So there is no any function, that means 1 is there and dx dy. So this is formula of area, okay, area of that region. So this is equal to 4 into area of D. Area of D. D means a given region. Okay, so let us see what is the given region we have. So what have they mentioned? C is a triangular region. Getting C is a boundary of that triangle. So that means D is that triangle. So let me draw here so you can easily understand. Y-axis, x-axis. Okay, so this is our y-axis, this is our x-axis. So what are the vertices of that triangle? 0, 0, 3, 0, 1, 2, 3. 3, 0 will be here. 3, 2, 3 and 1, 2. So 3, 2 somewhere here, 3, 2. So these are vertices of triangle. Let me join them. So we get a triangle. This is a triangle we have, right? So D is nothing but area of that triangle. So yeah, area of triangle D. Getting area of triangle D. See, in our schools we have already seen the formula to find area of triangle. What is the formula? 1 by 2 into base into height. The same formula I am going to use to find the area of triangle D, right? So 4 into that formula is 1 by 2 base. Okay, what is the length of that base of that triangle? It's 3 into height. Its height is yes 2, so it will be 2. So 2 will get cancelled and final answer will be 12. So value of right hand side is 12. Let me call it as equation number 1. So we solved right hand side and we got its value 1. So now we are going to work on left hand side. Okay, so finally we should have the left hand side should be 12. Then from 1 and 2 you can say both of them are equal and Green's theorem will be verified. That will be our conclusion, but before that we will work on left hand side. So make a screenshot of it first, then we will go further. So let us start to work on left hand side now. Okay, so let me write here left hand side. So it is integration over C p dx plus q dy. Okay, p and q I have already written here. So this is our left hand side and we have to find its value. So we can write this side in this way also, integration over C pi plus qj dot dxi plus dyj. Okay, as a product of dot product of two vectors I express. So we will denote it by f bar and we denote it by dr bar. So where obviously f bar is equal to what? Pi plus qj. So let me put the values. What is our p? It is 2x minus y plus 4i. Getting no? So I, that means you can write simply comma also you can write, and q, that is 5y plus 3x minus 6. You can write in terms of I and j or simply you can write as an element of R2, right? So yes, this is f bar is equal to this one we have. So now what we have to do, we have to solve that line integral. Okay, line integral over the boundary of that region. But as you can see here, we have a triangle and it has 3 sides. So that means we have to solve the line integral over this side, and over this side. So let me denote it, call it as C1. This is side C1, this is C2 and this is C3. So therefore we can simply write line integration left hand side, which is equal to line integral over C f bar dot dr bar is equal to integration over C1 along this side plus integration over C2 plus integration over C3. That means we will find values of this line integral separately. Finally we will add them, so we will have the value of left hand side. Okay, so let us start to work on C1. So let us see along C1. To find the value of line integral, we should find the parameterization of C1 first. Okay, as you can see here, C1 is a straight line, right? C1 is a straight line which joins points origin to this point 3, 0. So if you have a line, there is a fixed technique to find parameterization. Let me write here along C1 the parameterization of C1 is, we denote it by alpha defined on closed interval 0, 1 to R2 as, okay, there is a fixed technique to find parameterization of a line. That technique is, okay, so this is a part we have. So alpha of t is equal to what we do? 1 minus t into starting point, getting? Yes, starting point is 0, 0 plus t into end point, which is 3, 0. So this is a fixed technique to find parameterization of any line segment, getting? So starting point, and see this direction I have taken because in a problem they have mentioned, okay, they have mentioned in anti-clockwise direction. Okay, in positive sense they have mentioned, so that's why I can consider the anti-clockwise direction. Yes, so this is the starting point and this is the ending point. So starting point into 1 minus t plus ending point into t. So this is a fixed parameterization we have. Let us solve it. 1 minus t into 0 will have 0, 1 minus t into 0, 0, t into 3, 3t and t into 0, 0. So let us add component wise 0 in plus 3t, 3t and 0 plus 0, 0. So this is alpha of t. So let us find alpha dash of t now. Alpha dash of t derivative alpha dash, its derivative will be, derivative of 3t is 3 and derivative of 0 is 0. Okay, as well as we have to find f of alpha of t also. So let us find f of alpha of t. So f of, what is alpha of t? It is 3t comma 0. So now we have to operate f on that. What is definition of f? This one, getting? See, at a place of x, we have 3t, and at a place of y we have 0. So here also I will do same. At a place of x I will write 3t, and at a place of y I will write 0. So tell me what will you get? Here 3t, so 3t into 2, 6t, right? Y 0 plus 4, okay, comma, y 0, so forget it, x is 3t, so this is 9t minus 6. So this is f of alpha of t, okay. So let me write here, we have some space, so let us use integration over c is equal to integration. So our parameterization is defined, that alpha is defined on closed interval 0, 1. So the limits of integration will be 0 to 1. I hope still you remember how to find the value of line integral. So simply we take inner product here, f of alpha of t, alpha dash of t, okay, and dt. See, there is no more space to write, make a screenshot of it, okay. I am going to rough this part. Okay, so let us continue. So this is equal to integration 0 to 1 inner product of, what is value of f of t? Let me put it here. So it is 60 plus 4 comma 90 minus 6 comma alpha dash of t, its value is 3 comma 0 dt. So I hope you know how to find the value of inner product. First component into first component plus second component into second component. Let us do that. Integration 0 to 1, 3 into the first component is 60 plus 4 and second component is 0. 0 into anything, 0. No need to write anything, dt. So 3 will come outside. Integration 0 to 1, 60 plus 4 dt. So let us integrate 3. See, 6 is constant, its integration will, it will come outside when you take integration, okay. Integration of t is t square by 2. 4 is a constant, will come outside, so integration of dt is t 0 to 1. Let us put upper limit, lower limit. So this is 3, I am putting upper limit 1, so 6 by 2 only. If I put 1 here, 4. If you put lower limit 0, 0 into anything 0, 0 into anything 0. So I will not write that thing. So this is equal to 3 and this is 3 plus 4. So it is 7 and answer will be 21. So therefore, let me write here, line integration over C1 is 21. Its value 21. Okay. So let us go further. Okay. I'm going to rub this part, make a screenshot of it. Then we will go further. So now let us find value of line integral over C2. Okay. So let me write along C2. So see, C2 is a line segment which joins these 2 points 3, 0 and 3, 2. So let us find its parameterization first. So parameterization of C2, is, okay, so I have told you one simple technique that let us call it as beta. It is always defined from closed interval 0, 1 to R2 as beta of t. The technique is 1 minus t into starting point. So C2 starts here 3, 0, getting, plus t into end point. So the end point is 3, 2. Okay, so yes, in this way we define the parameterization. Let us simplify it. So 1 minus t into 3, 3 minus 3t, and 0 into 1 minus t is 0, plus here also I will multiply. Okay, 3 into t, 3t, 2 into t, 2t. So let us add them. Component wise we will add a first component. So 3 minus 3t plus 3t, comma, we will add second component 0 plus 2t. So minus 3t plus 3t will get cancelled to each other. We will have 3 only and here 2t. So this is beta of t. After that we should find its derivative beta dash of t. Therefore beta dash of t. We will find derivative component wise. Derivative of 3, 0 since it is constant, and derivative of 2t is 2. Okay. So let us find f of beta of t now. F of beta of t. See, all these things are required to find a value of line integral. Okay. In definition of line integral, we use all these things. So we are finding f of beta of t. Let me put beta of t here. So this is 3 comma 2t. See, purposely I have written the definition of f here so you can easily see and answer my questions. Okay. So see, at a place of x, what we have 3. At a place of y, what we have 2t. So we are going to follow the same definition. Simply I will put these values there. Okay. So let us see what we'll get. Let me write here. So this is equal to what is value of x? 3. So 3 into 2, 6 minus value of y 2t. So 2t plus 4. Okay. Y. What is value of y? 2t. So that 2t into 5, 10t. Value of x? 3. So 3 into 3, 9 minus 6. Okay. So let us simplify it. It is 10 minus 2t and this is 10t plus 3. So this is value of f of beta of t. Okay. So let us find the value of line integral. Then integration over C2 is equal to integration. See that C2 has a parameterization beta. It is defined on closed interval 0, 1. So limits of that integration will be 0 to 1. Simply I will follow the definition. The definition says inner product of f of beta of t, okay, comma, beta dash of t dt. This is equal to integration 0 to 1. Let me put the values. F of beta of t just now we have calculated and we have got its value here. Let me write. So it is 10 minus 2t and 10t plus 3, comma, beta dash of t. Where is my beta dash of t? Here. So its value is 0 comma 2. So when we get 0, I feel very happy since when you multiply anything by 0, you will have 0 directly. Let us find the value of this inner product. So what we do? First component into first. So 0 into anything 0, no need to worry. Let us go for the second component, 10t plus 3 into 2. So that means we will have 20t plus 6 dt. Let us integrate. So 20 is a constant, will be as it is. Integration of t is t square by 2 plus 6 is a constant. So its integration will be simply 6t 0 to 1. I am going to put the upper limit first, then I will put lower limit. If I put 1, we will have 20 by 2, and here if I put 1, so 6 into 1, 6. If I put 0, we will have 0, so I will not find that thing. So this is 10 plus 6, 16. This is the required answer. Okay. So required answer, that means what I want to say, the value of line integral over C2 is 16. So still that C3 is remaining. So let us work on C3 now. Make a screenshot of it first, then I will go further. Okay, so let us find line integral over C3. Okay, C3. So as you can see in this diagram, C3 is again a straight line. So we can apply the same technique to find its parameterization. So I am denoting it by gamma. Okay, it is defined on closed interval 0, 1. Since it is a line segment, we join these 2 points. So our technique says gamma of t is equal to, yes, 1 minus t into starting point, which is 3, 2, right? Plus t into end point, that is 0, 0. Let us simplify. 3 into 1 minus t, we will have 3 minus 3t, and 2 into 1 minus t, 2 minus 2t. Plus here I will multiply t into 0, 0, t into 0, 0. If you add component wise, if you add 0, you will have the same term. So I will save my time. I will not write that thing. 3 minus 3t and 2 minus 2t. So after finding parameterization, we find its derivative. So gamma dash of t, component wise derivative. Derivative of 3 is 0 since it is constant, right? Derivative of t is 1, so minus 3 will be there as it is. Derivative of 2 is 0, forget it. Derivative of minus 2t is minus 2. So this is gamma dash of t. So let us find f of gamma of t. And okay, f of gamma of t. Let me put gamma of t here first. F of, what is it? 3 minus 3t and 2 minus 2t. So gamma of t I put here. So what is definition of f? this one. Getting this definition we have to follow now to find its value. So this is x, this is y. Okay, at a place of x, I'm going to put this one, and at a place of y, I'm going to put this one. So let us see what we'll get. 2 into x, that means 2 into 3 minus 3t, minus y, that means 2 minus 2t plus 4, comma. The first part is over. Now let us work on second part. So y, 5, what is y? 2 minus 2t, okay, plus 3x. X is 3 minus 3t plus minus 6. That's it. At the end we have minus 6, okay. So it is going to be a little bit complicated. Don't worry, we will solve step by step. So I will multiply 6 minus 6t minus 2 plus 2t. If you have minus sign outside, the sign will get changed. Plus 4, here 10 minus 10t plus 9 minus 9t minus 6. So see, constant 6 plus 4, 10 minus 2, 8. Okay. Minus 6t plus 2t, we will have minus 4t, comma. 10 plus 9, 19 minus 6, 13. And minus 10 minus 9 minus 10t minus 90 minus 19t. So this thing we have. Okay. So let us follow the definition of that line integral. Okay. So therefore, integration over C3 is equal to, what is parameterization of C3? Gamma, and it is defined on closed interval 0, 1. So its limits will be 0 to 1. So definition says inner product of f of gamma of t, comma, gamma dash of t dt. So this is equal to 0 to 1. Inner product of f of gamma of t. Let me put its value. What is its value? Just a minute. One more bracket is there. Yes, f of gamma of t, this one. So 8 minus 4t, comma, 13 minus 19t, 13 minus 19t, comma, gamma dash of t, it is minus 3, comma, minus 2 dt. So you know well how to find a value of inner product. First component into first component. So it will be, I will directly take a product. So product of these two. So it will be minus 24 plus 20. And product of these two, it will be minus 26 plus 38t dt. Okay. So yes, so this is integration 0 to 1. So 38t plus 20, we will have 50t. Okay. And this minus 24 minus 26 minus 50 dt. So let us integrate 50. Integration of t is t square by 2. T square by 2, and integration of minus 50 is minus 50t. Let us put upper limit, lower limit. If you put upper limit 1, we will have 50 by 2, that means 25. And here if I put 1, minus 50. And if I put 0, we will have 0. So it is minus 25. So the value of line integral over C3 is minus 25. Okay. So we got the value of line integral over C1, over C2, and now over C3 also. Let us add them. So we'll have the required value of left hand side. Make a screenshot of it, then I will go further. So therefore, let me write here. Therefore, left hand side, which is equal to line integral over C p dx plus q dy. But C we have already expressed it at integration over C a bar dot dr bar. Okay. So line integral over C, but C, that means there are three parts of C, C1, C2, C3. So this is nothing but integration over C1 plus integration over C2 plus integration over C3. We have solved all these line integrals separately, and we have got its value is 21, this is 16, and this is minus 25. So it will be 37 minus 25, and it's 12, equation number 2. In equation number 1, we have got the value of right hand side, it is 12. And equation 2, we got the value of left hand side, that is also 12. So we can write here. So from 1 and 2, see both values are same. So we can directly declare left hand side is equal to right hand side. And we proved, so therefore we can say Green's theorem is verified. Getting? Green's theorem is verified here. That's it. In this way we verified. Okay. Make a screenshot of it, then we will stop. Thank you. Bye bye.